Okay, so in this lesson, I'm going to go over the basics of energy and power. Okay, so we've already gone over energy, so I'm going to go over this really quickly. Energy, from a physics perspective, is the ability to do work. In a sort of more practical perspective, it causes the things around us to happen. Energy is happening all the time, everywhere we go. It's happening all around us. It makes things happen. And if you recall, I want you to remember that energy is an amount of something. It's an amount of this thing that allows us to do work. It's the amount of this stuff that makes things around us happen. Okay, so we went over the example of, the toothpick versus the large cord of wood, the gallon of gas versus a lot of gas, and so forth. Remember, energy is an amount of something. It's a discrete quantity. Okay. Basic unit of energy in the US, we're using the BTU, which is the amount of energy it takes to heat up 1 pound of water, 1 degree Fahrenheit. This is a review. It's about the amount of heat in one match. So if you recall, we went over some different BTU content of different types of energy, and we'll go over this again in a second. So the really, really important thing, remember, energy units, and this at the bottom I highlighted this. You can convert any energy unit into any other energy unit. In fact, you can convert any unit of any type into any other unit of the same type as long as you know this conversion factor. So we went over the energy conversions, and again, when you work on this, I'll give you these as givens. So we know our energy conversion factors, a kilowatt hour to BTU, BTU obviously CCF to BTU, and so on, okay? So if you know one energy unit and you want to convert to another, you can do it as long as you have that conversion factor. Okay, so now on to power. Power and energy are very much related. So power is the rate at which energy is converted, okay? Power is energy per unit time, okay? Energy per unit time, it's a rate. So we'll go over this in a minute, but energy is an amount, power is a rate. So you can do the power of anything. So all the stuff that we talked about, you can talk about in terms of energy. You can talk about in terms of power. How much power can a battery put out? How much power does a human body able to convert? How much power, electromagnetic power, does the sun generate? How much power does the Delaware Tech use? How much power do we use in the world? So forth. So they're very much related. Energy and power are very intimately related, but they're just slightly different. So let me give you a couple examples. First one, here's an old, really ugly, but functional oil furnace. So furnaces are generally going to be rated in BTUs per hour. So what does this mean? Well, it means the number of BTUs of energy it can burn through in 1 hour. Okay? So this is a power rating. Why is this power? Remember, power is energy per unit time. So it's energy in BTUs per unit of time. In this case, it's the hour. So it's a power rating. Okay? Energy per unit time is power. And the asterisk there is, it's rated at 100,000 BTU. That means it's not going to spit out or generate 100 BTUs of heat because of inefficiencies. We'll go over that more later. Okay, so there's example number one. Let's go to example number two. Electronics are rated in watts. Watts is a unit of power. This one's a little more tricky, and this I found is the best way to remember it. A watt is a joule per second. Okay, so that's what a watt means. That's how it's defined. It means converting 1 joule of electricity every second. We don't really get into what that sort of means other than you know that's an energy unit per a time unit. So joule is a unit of energy. Second is a time unit. Joule per second, that means it's power. Any energy unit divided by any time unit is going to be power. So here's one way to think of it. If you want to think about the relationship between, because we've talked about kilowatt hours before as energy, and now we're talking about watts as power. So this can be very confusing for people. So this is one way to think of it. If I use 100 watt hours of energy in 1 hour, okay, how many watts of power? So this is energy per unit time, okay, energy per time. So all you have to do, if you divide those two, 100 watt hours divided by 1 hour, what's going to happen is the hours are going to cancel out and you're left with 100 watts. Okay? So that's another way to think of it. Believe me when I say this is one of the most commonly confused things is that watts is actually a unit of power and watt hours is a unit of energy. So just think of a watt as a joule per second and hopefully that'll be enough to determine for you that it's power. So let's just look at a few things, okay? So here are some units of energy, some units on the left. we want to know are they energy or power, and you want to know how many watts they are. Okay, so go ahead and fill that in mentally if you'd like to. So a joule is a unit of energy. Anything that's a watt or a kilowatt or a megawatt or a gigawatt or whatever, anything that's a unit amount of watts is going to be power. Power, power, power. A BTU, as we know, is energy. Now BTU per hour, we know, is power. How many watts? So obviously these convert really easily to watts. And then this is kind of obscure. We'll look at that later. But one thing I wanted to point out is that if you want to convert a joule to a watt or BTU to a watt, the bad news is you can't do it unless you have a time component. So joule is energy, watt is power. You cannot convert the two together without adding that time unit. A BTU is energy, a watt is power. You cannot convert between the two unless you add the time unit. Okay? So again, sorry that got cut off, but basically you can convert any unit into any other unit. Excuse me, you cannot convert one unit into another unit if they are different types of units. That's really important. Okay, so if they are not the same type, you can't convert between the two. You can't convert between distance and time. Okay, it just doesn't, distance doesn't equal time. You can't convert between, weight and distance. I mean, it just doesn't make sense. So just think of it in those terms. You cannot convert energy to power unless you have the intervening unit of time. Okay? So let's just try to think of this, what this sort of means. So a 25 watt CFL, so you have your 25 watt CFL, sorry, got cut off, versus 100 watt incandescent. These actually spit out the same amount of light, but a CFL uses about 25% of the power of an equivalent incandescent light bulb. So we know it's wattage, right? 25 watts, 100 watts. Those are power ratings. So what does this mean in terms of energy use? Okay, so what this means is the incandescent will use energy at a faster rate. Remember, power is a rate, energy is an amount. So this is going to use energy at about a 4 times faster rate than this. So if you leave them on for the same amount of time, this is going to use about 4 times the energy. Okay? So you can think of it as joules per hour or watt hours per hour or whatever you want to think of. Okay? So this is the last thing. The really important thing is that energy only indicates an amount, not a rate. Okay? Energy is an amount. Power is a rate. So you need to know the time component to determine the power use. So if I say I used about 10,000 kilowatt hours, what does that tell me? That only tells me the amount of energy I used. If I say I used about 10,000 kilowatt hours last month, that tells me the rate. So that's effectively a power unit. What if I say I burned 20 gallons of gas? Okay, I just say I burned 20 gallons of gas. What does that mean? Well, that just tells me how much gas I burned. It doesn't tell me for how long. So this is very different than I burned 20 gallons of gas yesterday versus I burned 20 gallons of gas last year, okay? So that's an illustration of this is just energy. It tells you how much, the amount of energy you use. This tells you the rate at which you're using energy. And this is a clear example of this is a much higher rate than this, okay? So that's meant to help drive home that energy just tells you how much you've used, how much you've converted. The power is telling you how quickly. So power kind of gives you this snapshot. It tells you the rate at which it's being used. Now it could be over an instantaneous, just for an instant. At that exact instant we're using 100 watts, or that exact instant we're using 25 watts, or it could be averaged over a period of time. So we could actually calculate the power use based on this and the power use based on this. Okay, so really all it means is just this snapshot. So just think of a power rating as how quickly is it going through energy. So something that's using 100 watts is converting energy at a lot faster rate than something that's using 25 watts. Okay, so that's the basic relationship between energy and power, and in the next lesson we'll learn how to do some calculations with this.